Now, so far in doing integration, we've done two methods. The simple integration, which when you did the homework, I'm hoping you also felt was simple to do, and also the u substitution. Now, while it takes a little bit of getting used to, how do you do these steps and getting familiar with it takes us a little bit, but then I'm hoping at some point then, which it feels familiar, that it also doesn't seem too difficult. Now today we're going to get into integration by parts, and the process or what's behind what we're doing is not necessarily too difficult. It's actually just going to simply be a formula that we use, and that formula will use simple integration or the integration by u substitution. So it's simply taking the two things we know and applying it to a formula. So concept-wise, it's not too hard. Process-wise, it's not too hard. But in working out the problems, it gets a little bit harder. And we'll see why in just a second. It's not that it's impossible to do, but most students feel this is the hardest of the three integration processes that we teach in this course. With integration by parts, we use a formula. And again, it's similar to u substitution, where when we do the integral of one function times another function, that it's equal to this formula, f of x times capital G of x. Now when we're doing capital G, it's like the, before, the capital means we're doing the antiderivative. So capital G of x is the antiderivative of small g of x. Back to the formula again. So it's f times g, capital G, minus the integral of f prime of x times, again, capital G of x. Now, the shortcut that I like to use, it eliminates the x's. It's just nice for memorizing it. Technically, it's not correct because you need to have the x's in there, but we get a good feel for this. It's simply f times the integral of g minus the integral of the first derivative of f times, again, the integral of g. There. Now, when we're doing this, the formula is not too hard. Of course, memorizing it's not difficult. However, we realize, if we think about it, to get this capital G, we need to find the integral of small g. And then, once we have that, we're going to use it again, multiply it by f prime, and take the integral of that. So it feels like we're doing integration twice in the same problem. And yes, we actually are. So usually that's what makes it seem a little bit harder for students. It just takes more time. One problem can take 5 to 10 minutes, depending on how fast you are in working with math. The simpler ones won't take that long, of course, but just realize that these problems will take a little bit of time. So not enough time for the homework. Now in doing this, here's an example. We're going to take the integral of x times x minus 2, the quantity to the fourth power, dx. Now I'll point out here, since we're doing a similar thing as u substitution, as far as how the problem looks, I should say, it's one function, in this case our f would be x, times g, and g would be x minus 2 to the fourth. Now, say, well, if that's the case, couldn't I just use u substitution? Well, u substitution, I pointed to it earlier in the prior video, that if you take the derivative of just what's inside the parenthesis, in this case, the derivative would simply be just 1 for what's inside the parenthesis. When we did u substitution, then this other function that we're multiplying it by is the derivative or a part of it. Now, in this case, if that's the case, then you can do u substitution. In this case, 1, x is not a part of 1 at all. No way you can go from 1 and multiply it by anything except x to get x. You can't divide it like we did with u substitution to get x. So we realize that when we're doing this, if we take the derivative of what's inside of the parenthesis and only inside the parenthesis, and the other function that we're multiplying it is not the derivative or even a part of it, then we have to use integration by parts. So that's what we're doing here. To do integration by parts, of course, we need our f and our f prime, and when we do that, of course, we're going to differentiate. We find the derivative. But then our g will be the second one, the second function, like we said, And with that, we're going to integrate. We're going to go from G to capital G. And in this particular case, we want to do the integral of the quantity x minus 2, quantity close to the fourth power, dx. So we know this is in a form that we can't just use the simple integration. We have to use u substitution to find capital G. Well, of course, we go through u substitution. Let u equal x minus 2. Now, I'm going to use the shortcut method for this. The next part is you take the derivative of u, which is du over dx equals 1, and then multiply both sides by dx. And putting that together in one step, that's du equals 1 dx. So we can do our substitution. It becomes the integral of u to the fourth, and since du equals dx, it's simply du at the end. Now we can use our simple integration to get 1/5 u to the fifth, of course plus c, and then we substitute back in the x minus 2 for the u to get 1/5 x minus 2 to the fifth plus c. And that we put back up for g. So I'm going to move that back up there and get rid of the extra. And now we did the first integration. That's just to find our capital G. Now we apply the formula. So we do our f capital G minus the integral of f prime capital G. And our f is x, so we put that there. Our capital G is 1/5 times the quantity x minus 2 to the fifth, 1/5 x minus 2 to the fifth, minus the integral of f prime, minus the integral of f prime up here. F prime is 1 times g. G again is this 1/5 x minus 2 to the fifth, 1/5 x minus 2 to the fifth. And now we take the integral of this. Now in the first part here, usually we're used to seeing this in a slightly different order. So we can make this 1/5 x times x minus 2 to the fifth. Now, this first term is in essence finished for now. Actually, it'll be finished for the rest of the problem in the way that we're going to be doing this. But we just need to keep it there and not forget to write it. Now, minus the integral here. 1 and 1/5, of course, multiplied together is 1/5, and any number that's inside of here, any constant, can move outside the integral. So it's minus 1/5 the integral of x minus 2 to the fifth. Now we can take the integral of this, but again, it's using u substitution. So here we need to do u substitution the second time. So once again, let u equal x minus 2, take the derivative of u, and multiply it by dx, and we get du equals 1 dx. And we do the substitution, then it becomes the integral of u to the fifth for the first one, and then the dx is replaced by du, and we get 1/6 u to the sixth. We substitute back in our x minus 2 for u, and we put all of that in place of this here, of the integrand. So it becomes minus 1/5 times the 1/6 x minus 2 to the sixth plus c. Now, we have some like terms here, and we can multiply these together. And we get 1/5 x times x minus 2 to the fifth minus 1/30 times x minus 2 to the sixth plus c. Now, if you're looking at this, saying, oh, there's things that we can factor out. But let's not do that for this section. We've done that kind of factoring before, so we've developed the skills, and let's just simply leave it in this form. If we were math majors, maybe we'd be more concerned with getting it simplified as far as we can, but maybe since we're business majors and we can use this, and it's not too difficult, why don't we just leave it in this form? So none of that extensive factoring that we did in the prior section. And you won't be required to show it in the homework. In fact, in the book, sometimes the answers in the back give it to you just in this form as well. And on the exam, I won't require it. Now, so hopefully this doesn't seem too hard, other than the fact you have to take the integral, and then take the integral of that times f prime again. But hopefully the formula makes sense, and you already know the simple integration rules, you already know the U substitution rules, so it's not too difficult. Now, just a few more problems, just to make sure that we are up to speed on this. When we're looking at this again, if we just had this problem on an exam, of course we'd look at it and say, well, it's more complex, we can't use simple integration. Well, we really hope we could do U substitution because it's faster, but if for U substitution to work, we have to take the derivative of what's inside of the parenthesis. That's going to simply be 2 in this case. And this function x is not a part of 2. There's nothing you can do to divide 2 by anything to get x. So we have to use integration by parts. So we find our f prime. We also find our g and our capital G. And assuming you know how to do U substitution, that's going to be the integral of this. And I simply put the answer here, since you already know how to do U substitution. It's not too difficult. I will pause here a second at this point, because there's a few students that say, well, does it really matter? I mean, you're saying that the first function is f and the second one is g. Technically, it doesn't really matter. You can switch them around if you want, because it will work. The problem is that with these, all of the problems that you're going to do, the ones that I use in class and on the exams and in the homework, we have it set up that our f is first and our g is second. If you reverse them, you end up in the formula finding, once you find this integrand, that to find this you have to do integration by parts again. So you would find the integral of this, multiply these together. To take the integral of this, you have to set it up and do integration by parts again. So you end up making it harder, having to take the integrand 4 times, and then sometimes you get to that answer, you have to do it again, and you end up taking the integral 6 times. So the technical answer is, eventually it will work out and you get the same answer after doing an immense amount of factoring, but you can switch them, but you make your life rather miserable in the process. So keep them in the order that we have it. We have it set up that it's the simplest, the easiest to do. If the first function, even if it's just x, is your f, and your second function is your g. And usually the g is the one that's in the parenthesis raised to a power. It just will make your life much easier doing the homework and then the exam. Now, back to the problem. Now that we've figured out our f prime, g, and capital G, now we use the formula. So the integral of this function is going to be our f times our g minus the integral of f prime times our g, again capital G when I'm saying it in this case. And the first term always works out relatively quickly. You get 1/8 x times the quantity 2x minus 3, quantity closed to the 4th power. The 1 times 1/8 is, of course, 1/8. It's a number, so you can move it to the front of the integral sign. And we take the integral of this. Again, we use U substitution for this. And when we do this, usually you'll want to write it out just to go through it, but I'm assuming that you know how to do this and you can work this out on your own. That the integral of 2x minus 3 to the 4th works out to be 1/10 times the quantity 2x minus 3 to the 5th power. Now you multiply these together, and we end up with this. Again, we could factor it out, but we don't have to. We'll just leave it in this form for this section. So we get 1/8 x times 2x minus 3 to the 4th minus 1/80 times 2x minus 3 to the 5th plus c. Again, please remember the plus c at the end. We haven't determined what that constant is yet, so we need to leave it as plus c. Another example using square roots. Just as before, we always need to convert the square root to some power. And of course, the square root is going to be the 1/2 power. And now we have our f and our g. Again, the derivative of what's inside here is simply going to be 1. And there's no way you can get 1, take 1 and divide it by anything to get it to be x. So we have to use integration by parts. we again find our f. Our f prime then is simply 1. Our g is this, so our capital G is going to be the integral of this. When we use u substitution, we'll let u equal 2x plus 3, and we find that it's a 1-to-1 relationship, that you take the derivative of, of x, you get 1, so du equals 1 dx, so we can simply do the straight substitution. And working then with the formula, we find out that g is going to be equal to, capital G, excuse me, is going to be equal to 2/3 x plus 3 to the 1/2. So again, I'm not showing this because I know you know how to do u substitution and the simple integration. Since u substitution uses simple integration, you need to know both of these to be able to do the integration by parts. And so that's the g. We put it into the formula, and we get our f times our capital G minus the integral of f prime times capital G. And of course this becomes 2/3 x times x plus 3 to the 3/2. And again, the 2/3 times 1 is 2/3, and that can come outside the integrand sign. Times, so it's minus 2/3 the integral of x plus 3 to the 3/2. We do u substitution and find that that integral is equal to 2/5 x plus 3 to the 5/2. We have to multiply the common, or the terms here that we can, and we end up with the final answer being 2/3 x times x plus 3 to the 3/2 minus 4 over 15 x plus 3 to the 5/2 plus c. Now I know that was kind of fast, but with this video presentation, I'm assuming you know how to do the u substitution, and you can do that, so I didn't bother to show it for 2 of the 3 problems. If you're struggling with that, make sure you get it down, because obviously we need to use this. U substitution will show up a lot on the upcoming exam. Now, just to make it clear, as you can imagine on the exam, I'm simply going to give you problems and ask you to integrate them. The homework has been set up that first you did the simple integration, then you did u substitution, now we're doing integration by parts. But how do you know when to use what? Because on the exam, obviously, I'm not going to tell you which one to use, you have to figure it out. Today's homework has you do a couple problems where you figure out which one you need to do, but a simple way to look at this is that if you had a simple formula, even if it looks hard, it's simply one term plus or minus another term plus or minus another term and so on. Well, if it's something like this, then you can use the simple integration formulas and all of the different rules that we learned with that. And that's the easiest one to do. If you end up having something that has, it's inside a parenthesis raised to a power. For example, if you had 5x squared plus 3, all raised to the 4th power, we know we can't use the simple integration formula. If it was taking the integral of just this, of course we could do u substitution with this. The other thing is that if we have this kind of setup, something inside a parenthesis raised to a power, and it is also multiplied by something else, and that other function, that something else that we're multiplying it by, is the derivative or part of the derivative of what's just inside of the parenthesis, then we use u substitution. So back to our example, if this was 5x squared plus 3, if this was also multiplied by a function that was, say, 10x, for example, well, the derivative of 5x squared is 10x. So if we're multiplying 10x times this, well, 10x is the derivative of what's inside the parenthesis. So we know we could use u substitution. If it was 5x, that's a part of what's inside it. It's a part of the derivative. 5x is part of 10x. If it was 2x, it's a part of the derivative. Even if it was just multiplied by x, x is a part of 10x. That's 1/10 of it, of course. Since x is a part of 10x, then you can use u substitution. And then, of course, the last step is, if it's multiplied by something else that is not a part of the derivative, then you have to use the integration by parts. If you were using a different example, if this was simply x plus 1 to the 10th power, and it was multiplied by x squared, well, x to the first power, the derivative of that's going to be simply 1. And there's no way you can divide 1 by anything to get x squared. So then that means you have to use integration by parts. So keep this in mind on the exam. In the homework, just think about it a couple times. As you're working through it, there's a couple problems where you have to apply this, but it gives you an idea. This hopefully serves as a good guideline to what you need to do. And the homework comes from chapter 9, the second section. Not a lot of problems, but they take time. As you can imagine, taking the integral twice, oftentimes you're doing u substitution twice. So allow yourself some time. Of course, class will give you a good start on it, but you may not finish the problems in class. Just keep that in mind. So, have a good day. We'll see you in class. Again, this is on Moodle.